Assalamualaikum and hi. In this video, we're going to show you guys our case study which is about the queuing theory project. We want to see how the waiting line at the coffee bean and tea leaf went. First of all, I'm going to introduce my group members. Firstly, we have Nazirah Binti BORHAN. Secondly, we have ATHIRAH Binti ISHAK. And lastly, we have NURUL NAJWA Binti HUSSIN. For the introduction, we want to study the waiting line at the coffee bean and tea leaf almond center Kedah queuing system. We do an observation from 3:45 PM until 4:45 PM within 1 hour. Only one number of servers at that time. This is the situation at the coffee bean and tea leaf almond center Kedah when we made an observation.
Next, characteristic of queuing system. Arrival characteristics. The size of the calling population is unlimited. Pattern of arrivals at the system is arrivals are considered random. Assumption for arrivals at service facility follows the Poisson distribution. In our study, there are 10 customers per hour. The behavior of the arrivals exists, which is patient customer. They wait in the queue until they are served. Next is waiting line characteristics. The length of the line is limited. The queue discipline is which is the order in which customer are served is first in, first out. Next is service facilities. The configuration of the service system. First, number of channels. In our study, number of channel is single channel system. The number of phase is single phase system. And the pattern of the service is assumptions for service time follow the exponential distribution. In our study, there are 13 customers per hour. The last is basic queuing system configuration. In our study, there are single channel, single phase system.
Next, we are going to look at the result and the conclusion of our study. Then, after observing our customer in the coffee bean and tea leaf, we would like to make an assumption of the model and conclude it. Using our data that are being collected for 1 hour in the cafe, the arrival rate, which is lambda, equal to 10 customers per hour, while the service rate, mu, is 13 customers per hour. In order to find out the average number of customers in the system, we use the formula of L, that is lambda over mu minus lambda. Then, we get 3.3 or approximately 3 customers per hour. To know the average number of customers in queue, we use LQ formula, which is lambda squared over mu multiplied by mu minus lambda, and it is equal to 2.56, or to be exact, 2 customers per hour. We also would like to calculate the average time a customer spends in the system, so we use the formula W, which is 1 over mu minus lambda, and it is equal to 0.33 hour, or can be said 19.8 minutes after 0.33 is multiplied by 60. Then, we also want to determine the average time a customer spends waiting in the queue, so we use the formula of WQ, which is lambda over mu multiplied by mu minus lambda, and we obtain the average time of a customer, which is 0.256 hour, or approximately 15.36 minutes when 0.256 is multiplied by 60. Then, we are going to figure the utilization factor for the system, that is, the probability that the service facility is being used. We use the formula ρ equal to 0.77, which is 77%. We may say the service is busy and it is fully utilized. Last but not least, we may conclude that the number of servers provided by the coffee bean and tea leaf is adequate because the waiting time for each customer is maximum approximately 50 minutes. The customers are also happy because they get served on time. During conducting our project, we learned to understand well about the assumption of the common model that will in this chapter, as well as we understand on how to describe the basic queuing system configurations.
Thank you for watching.